Hi everyone, okay, now we're going to go ahead and solve Ribbit. So our first rule says that K and M are separated by exactly one space. So if we were to put the M first, the K would have to go in 3. But also, those can switch off, right? We weren't told who goes first and who goes last. So it's important that we add our arrows at the top to show that we don't know what order they're going to be going in. Our second rule says that J and K are non-consecutive. So J and K go in a box with a switch or with the arrows that show that they can switch off. And we have a slash going through it because J and K cannot be placed next to each other. But we also need to illustrate that in either order, that is not okay. So J and K can't go next to each other. And our third rule is simply that M can't go first. So we can add that straight to our board, that M is not allowed first. So we'll put it underneath with a slash going through it. Now lastly, we should take a note of all the game pieces that we have talked about. L and N are our floaters, they are wild cards, they can go anywhere that they need to go. So with that in mind, let's jump into that first question. What could be the correct ordering from 1 to 5? Well, if we test the K and M being exactly one space away, that should get rid of 3 of your options. Our second rule says J and K can't be next to each other, and that should leave you with only one remaining correct answer choice. Our second question says, what is the maximum number of lily pads that could separate M from N? Well, if we take our M and we were to put it in the first spot, well then we can't do that because the M is forbidden from that first spot. So how about instead we put the M last with the N, the thing that we're trying to separate it from, in the first spot. That would maximize us and give us 3 spaces in between. When in doubt, let's put the M in the spot that is the least constrained. Now, if we do that though, we look at the M, and according to our first rule, K then must be put 1 space away in 3. And the problem with that is our second rule tells us that the J has to go, it would have to go in either 2 or 4, and no matter which way we do that, it's not allowed because of rule 2, J and K are non-consecutive. Okay, so back to the drawing board for a quick second. We know we're going to leave our J and K up above, and we know that the M and the N are what we're trying to separate. But if we move the N over just 1 space, we try the next logical option. Can we just have it 2 spaces away instead of 3? Because 3 wasn't allowed like this, but also we couldn't have them fully separated in this way because of the M. So going back to that where we had it originally with the M in 5 and the N in 1, now let's try the N in 2. Now we've got 2 spaces separating. Hopefully this will work. And if we do that, we realize the K, again, has to go exactly 1 space away from the M, but the J now has room, right? It doesn't have to go in 4 where it would break the rule. We can put it in 1, and that leaves just L to go in 4. And so the maximum separating M and N looks like 2. We've got those golden lines underneath. Next we're asked, if K is first, what is a complete and accurate list of all the frogs that could be seated second? Well, if we put K first, what rules talk about K? Well, there's 2 of them. The J can't go in 2, but more importantly, we can put the M in 3. We know the M has to go in 3, but the J isn't allowed in 2. It can't be touching that K. So we put the J up here with some arrows. It can go in 4 or 5. Now we still have the N to deal with as well as the L. So N and L, we don't know where they're going, but we know that they could both go in 2 because they were floaters, right? So the N and the L have a split option. We don't know who's going in 2, but one of them has to. So it's going to be N or L in the second spot. Third, we're asked, if K is third, what must be true? So if we put K in 3, we realize that the M has to go in either the first spot or the 5th spot in order to separate it by exactly 1 from K. And if we put M in first, we realize that we break rule number 3, so we have to put M in 5th. That is a must be true, and we can check for that. But unfortunately, they don't give us the M being 5th as an option. But next we look at the K, and what rules do we know about K? Well, the J can't be in 2 or 4. So J must be forced into 1. That is something that we can say must be true. And J first is an available option, so we'll take that. Now lastly, just to solve the board, we had the L and the N, and we don't have any rules about L and N, so they are allowed to trade off. We don't know who's going where. Okay, so now we're going to see all the places that K could go. And I copied over some of our old game boards, and we can see that K can go in 2, 3, or 1. And so that tells us that if K can go in 1, 2, or 3, we need to test now, according to these possible answer choices, if K could go into the 4th or 5th spot. We still have 3 answer choices remaining. So first we can test for K going into that 4th spot. If we put K4, well, the M has to go 1 away. It can't go off the board, so that means it's going to have to go here into the 2nd spot. The J can't go next to the K, which means it's allocated to the 1st spot. And then we just have L and N switching off, so it does look like, indeed, the K is allowed into that 4th spot. Now down here, we still have to test for that 5th spot, because just because K can go in 1, 2, 3, and 4 hasn't eliminated all our answer choices. So can K go into the 5th spot is the last question that we need to answer. So if K is put into the 5th spot, we know that M, being separated 1 spot away exactly, is going to go into the 3rd spot. We know the J can't go into 4 because it would be next to the K, so the J is going to float up above, going in either the 1st or the 2nd spot. And the L and N are relatively unconstrained, right? So the J is going in either 1 or 2, and these L and N, remember, they didn't have any rules, so they could totally float around. Put some circles around them. Right, so one possible game world. So yes, K can go in 5, and we see that K works in all possible spaces. But just to make this notation a little easier to see, you can see that, say, we could put the J in 1, the N here, and the L here, because the only rules that we really had to worry about were keeping this M and the K separated by exactly 1 spot. And as long as we didn't put a J here, we're good. Those were the only 2 rules. Oh, and the M could not go in 1, but we weren't worrying about that anyways because none of these game boards did that. So we see that K can go in 1, K can go in 2, K can go in 3, K can go in 4, and K can go in 5.